Here we're going to examine the power law of logs, and the power law of logs is stated here in general terms. And what it basically says is if we have a log to any base and its stuff has an exponent on it, in this case there's an exponent of c, it's the same thing as just bringing that exponent c down in front like here and saying it's c times the log of a, with the stuff being b. So we'll look at it through some examples and have some work to do here at the end. So the first guy says simplify log x squared. If we examine it, our stuff has an exponent of 2 on the front, so that 2 simply can drop down, and we get 2 log of x simplified. The next example has an addition of 2 logs. If we examine, they're both base 10, both of them have a power. The first one has a power of 2, the second one has a power of 4 on the stuff, which means both of those can now drop on down in front of the log expression. So we'd have 2 log x plus 4 log x. The exponent on the stuff comes down in front. The tendency would be to leave this as it is right now, 2 log x plus 4 log x. But if you examine it closer, they're basically just like terms. We have 2 log x's plus 4 log x's. We should simplify that to be 6 log x. Example 3, you really have to examine and pay attention to this type of question. It is sort of a trick. If you look at it, it does have an exponent. So the tendency would be say, okay, that exponent can come down and I'm left with 2 log x. Unfortunately, that would be incorrect. If you examine back up here, the power law for logs, the exponent has to be sitting simply on that stuff, not on the whole thing. So this here is not sitting on the x, it's sitting on the log expression itself. So this one here cannot be expanded unless the only expansion we looked at was to say log base 10 of x all squared is the same as log x times log x. That's the only thing we could do to fix that up. The next example says condense this, maybe write it a little smaller, for 3 log x times y. Taking the power law backwards, we know that we have a coefficient out front of 3, so to take it backwards, I could put it back upstairs on top of the stuff, the xy. So this could turn into log xy all raised to the 3rd power. Now that's one acceptable answer. The other answer that we could look at is to say, all right, this 3 can now be put on both of those in there. So we could have log base 10 of x cubed and y cubed. Both of these, in my opinion, are acceptable answers. One just distributes the bracket in a little bit, or sorry, the exponent in. The next 2 examples kind of complement one another and take your thought process into 2 different places. Example 5 and example 6 both have logs, both have a coefficient out front. One has a 2, one has a 4, and both of them have what appears to be 2 terms after them. Example 5 has the x minus 1 in brackets. Example 6 has a minus x not in brackets. Now, we've been telling you for years that brackets are important in math, and here's a prime example. The x minus 1 here is considered the stuff of this log. So to condense this, I can put that 2 on the top. I can use the power law to say the x minus 1's here, with that being squared. I cannot do that in example 6. In example 6, the 4 does not go on to a minus x. The 4 would only go right onto the stuff of the log. So the 4 could be put back up as the exponent of log a to the 4th, and the minus x has nothing to do but sit there. Now if I jump back up to example 5, this is one possible explanation or possible solution. The other solution would be to say, I know that x minus 1 all squared is really x minus 1 times x minus 1, so I could take care of that exponent and say it's log of x squared minus 2x plus 1, foiling those two things out. In example 6, there's nothing I can do but just to leave it as it sits. Now you can work on the next page, which is the power law. It has some examples. These ones aren't too difficult, but to check your answers, go to puremath30.com and look up this lesson.